Hi, I'm Professor Primary 6 from YUMIN Primary School. In this time, we are still at ordinary differential equations. In the last lesson of ordinary differential equations, we had one simple question, but about its answer, we have explained it and even explained why is it like that and have done a verification. But just give you more information. In case you get confused within this, let me just tell you, this, what we have done, is a verification and not a proof, just a verification. Okay, let me tell you more about this answer. In this case, these two answers, or in this case we say as lambda, they're the same. But what if they're different? Now, what other name can you call it if these two are different? Let me just tell you, this is called a distinct answer. So, distinct answer, well, that would be very simple. Well, let me just show you how. If there's only these two, it'll just be like this for y. So this is very easy for distinct. But what if these are the same? So we can call that this answer is multiplicity. Yeah, you can call this answer of multiplicity. So if it is multiplicity, you have these cases. But when you read some books, you might see this symbol, mu. Or you might see others, or like r, different symbols. But let me just tell you, it doesn't matter. This is just saying what kind of letter you use to represent, well, in this case we call lambda. It's just a different type of representation. So that doesn't matter. That doesn't change the answer. It's just different books, different ways of writing. Okay, so it's just simple as that. But more commonly, we use lambda. Okay, so that's what we use more commonly. So next, we have another example to see whether we can straight away get this answer. So, well, for different types of questions, you might have different, well, highest order and different factorization for this, lambdas. Okay, so let's take a look at what type of example we have here. Okay, so in this case, what we have here is a third derivative. Then this, okay, let me just write this whole thing down. Okay, it becomes like this. So firstly, we let something. But is this a homogeneous differential equation? Check. Yes, it is. It is a homogeneous differential equation. Okay, so that means we can use our characteristic equations method. So let's let something. Well, for our characteristic equation, what type of method do we use? So, well, we use e to the power of something. And this something we don't know, something x. We call it lambda x. Okay, so we let y be this thing. If it is third derivative, that means we differentiate it 3 times. What would you get? Third derivative. That means you have lambda to the power of 3. And because when you just differentiate this e to the power of lambda x, it always remains there. It doesn't change. So that means from all of them, we can simplify that. Okay. Then second derivative, that means you have two of these. First derivative, one of these, well, simply you don't differentiate, then you get none. This part, it might seem a little bit hard, but let me just show you a method that we have learned before, the long division. So we can try to use that long division. Oh, let's try lambda minus 1, because from here, I can find you have negative. And if you just use plus, then impossible. So more possible is this lambda minus 1, and let's try. Yes, and we got it. This is alright. But how about this other part? It looks simple. And this other part, well, you can factorize it quite easily, just using the cross multiplication. So lambda square, most possibly is like this. 3. That means both of them have to be negative. 4. Well, 3 is 1 and 3, and it's perfectly alright. Okay, yes. Wait, what does this mean? You have 2 of this, one of them like this. Then that means you have 2 of these answers, that is this case, and one of the other, which is this. So for these first two, you can call it lambda 1, lambda 2. And this will be equals to 1. Then lambda 3 would be 3, like this. So what next? Well, easy, find y. So what is y? Now, you have to be aware that we have 3 constants here. So how about the first? You have e to the power of just x. Then the second one, well, we have said about it in the last lesson. Well, that's gotta be an x. Like this. Then this one, this is different. So, well, that's different. And you get it like this. So, if you meet any types of this question, it's just quite simple. You just have to be careful during this part. During this factorization, if they have higher power, then you just have to be more careful. You can still use this long division. Or just that sometimes you have to keep on trying, because this case is just right perfect. It is just minus 1. Different types of question, they use different, well, of these factors. So then after that, you have to be really careful here. So you don't need to be frightened if the book that you are using, it uses different of these symbols or letters. You can use anything you want. Greek letters, alphabetical letters. They can use all of those. But it's just one meaning. Okay. So what else for this part? Okay. If you have more of these, for example, in these two cases, we only have 2 of these lambda. This is 2, this is 3. What if there's more? If there's more, for example, until P, you have P of these answers. Then what do you have over here? First one, C1 e to the power of, this is lambda 1 x. Well, that means all of them are actually just the same. Then plus C2 x. Well, you can just write this as lambda 2 in order not to, well, confuse yourself. But for this, okay, all the way until P, the first one is 1. Okay, well, it's just actually just like a pattern. So you can write it like this. But because all these lambda are equal, you can just write it as lambda 1, or you can choose any one of them. But that is just the same. Okay, so you don't have to be worried if you have all these. It's just as simple as that. Okay, so are you all clear so far? Okay, so I think I can end this lesson over here. You have to be very, very clear of every step what you are doing. So that's my advice for you. Okay, so if you like our videos, don't forget to subscribe to our channel, and see you in the next lesson, and thank you for your watching.